On August 14, 2018, a 210-meter section of a Genoa highway bridge collapsed during a rainstorm. Cars fell 150 feet. 43 people died. 600 lost their homes. The bridge was 51 years old. Here's what makes it worse. People knew. In 2011, its own operator warned of intense decay. In 2012, a local leader predicted collapse within 10 years. 6 months before it fell, official tests found its cables had lost up to 20% of their strength. Nobody limited traffic. The bridge kept carrying tens of thousands of vehicles a day, hiding its decay by design. Stand today in the Polcevera Valley in Genoa and look up. A bridge crosses overhead, gleaming, white, modern, the work of Genoa-born architect Renzo Piano, opened roughly a year after the disaster. 43 lamps are built directly into its structure, one for each victim. It is an unmistakable piece of architecture. It is also a memorial, pretending to be a motorway. It exists because of the structure that used to be here, in the same air, on the same trajectory, carrying the same traffic for 51 years. That structure had a name in Italy that doubled as praise and as a curse: the Morandi Bridge. It was built between 1963 and 1967, and it was, by the standards of its time, a striking, even celebrated piece of engineering. On a rainy August afternoon in 2018, a 210-meter section of it, including a support tower called Pillar 9, the road sections on either side, the cables that held them, and roughly 30 vehicles, fell into the valley below in seconds. 43 people died. 600 more lost their homes around the impact zone. You can read this as a story about an old bridge that finally gave up. That reading is not just incomplete, it's wrong. Because the headline number isn't 51 years of wear. The headline number is the gap between when the danger was first documented in writing and when the bridge was finally allowed to fall down. The bridge's own operator, Autostrade per l'Italia, formally warned of intense decay in 2011. In 2012, the leader of Genoa's Business Federation publicly stated the bridge was at risk of collapse within 10 years and needed replacement. A government meeting recorded, in February 2018, official measurements showing the bridge's internal cable tendons had lost between 10 and 20% of their cross-sectional strength. That meeting was 6 months before the bridge fell. Nobody closed a lane, nobody diverted heavy trucks, nobody dropped the speed limit. The bridge kept carrying tens of thousands of vehicles a day, and the people driving across it had no way to know any of this. You do not need an engineering degree to understand what went wrong here. You just have to look at the design. In the 1960s, the Italian engineer Riccardo Morandi was given a problem with real constraints. Genoa is a coastal city. Sea air carries salt. Bridges built on this coast, with exposed steel cables, were expected to corrode faster and require frequent, expensive maintenance. Morandi's solution was elegant. Instead of leaving the steel cables of his bridge exposed to the elements, he wrapped them in pre-stressed concrete. The concrete was supposed to act like a vest, shielding the steel inside from rainwater, from salt, from the long, slow chemical war that the coast wages on metal. He believed it would reduce the need for ongoing maintenance. It is genuinely innovative engineering. It was praised at the time. The same year it opened, an Italian newspaper boasted that the bridge's concrete structure won't need any maintenance, and that its stay cables, protected from atmospheric agents by their concrete vest, wouldn't either. That promise was published as a selling point. Now look at the engineering it was selling, from the inside. If you wrap a steel cable in concrete, you have done two things. You have made it harder for water and salt to reach the steel, which is what you wanted. You have also made it nearly impossible to ever see the steel again, which is what nobody wanted to talk about. To inspect the cables, you would have to go inside the concrete, drill, sample, or use specialized equipment to look through it. None of which is fast, none of which is cheap, none of which is easy to do while traffic is still running overhead. This is the original sin of the Morandi Bridge. The feature designed to protect the cables from decay is the same feature that made it almost impossible to detect that decay when it inevitably arrived. The bridge was built to hide its own warning signs inside its own design, a construction defect with a 51-year fuse. For a while, the gamble looked fine. The bridge worked. It became a vital artery for traffic moving along the Italian Riviera, connecting Genoa to the rest of the country and beyond. It was used heavily by trucks. It was used heavily by tourists in summer. It became part of the country's infrastructure backbone. The maintenance everyone had been promised would not be needed was, in fact, not done at the scale the structure deserved, because, on paper, the structure was supposed to be self-protecting. Then Morandi himself broke the silence. In a 1979 report, 12 years after his own bridge opened, Morandi wrote that, sooner or later, it would be necessary to remove all traces of rust from the structure's reinforcements, fill the resulting damage, and coat everything in high-resistance elastomers. Read that again. The bridge's own designer, the man who had wrapped these cables in concrete to keep them clean, told the people who owned and operated the bridge that rust was coming, that patches would be needed, that a protective coating would have to be applied. He named the maintenance regime his own design would eventually require. That was 1979. By the 1990s, the situation was no longer theoretical. Inspections of one of the bridge's support towers found that about 30% of its internal cable tendons had already corroded away. The numbers, when laid out in plain terms, were chilling. Each tendon was supposed to carry up to 33,000 pounds. With that level of corrosion, the working load had fallen to roughly 15,000 pounds. The bridge was being asked to carry trucks that could weigh as much as 97,000 pounds. That's the moment a competent system stops the bleeding. Italy almost did. In 1993, a specialist proposed retrofitting external steel cables onto the most damaged support tower. It was a known, working technique. Bolt visible cables onto the outside of the structure to take some of the load away from the corroded tendons inside. Relatively quick, relatively cheap, effective. According to reporting, Italian engineers rejected the fix because the visible steel cables would have detracted from the aesthetics of Morandi's original design. Read that sentence carefully. A working repair existed. It was refused, in part, because it would have made the bridge look less elegant. Instead, what was carried out was patchwork, restoration work that one expert later called wholly ineffective. The damaged steel components that linked the stays to the towers were left exposed to Genoa's corrosive coastal air. The fix-it-cheaply approach kept the silhouette. It did not stop the corrosion. By the time the next decade arrived, the bridge was decaying, with the engineering community on record having seen the better option and said no. After 2010, the documentation stops being technical and starts being almost embarrassingly explicit. In 2011, Autostrade per l'Italia, the private company managing the bridge under government concession, issued its own report warning of the structure's intense decay. In 2012, the leader of Genoa's Business Federation publicly stated that the bridge was at risk of collapse within 10 years and needed to be replaced. A political party dismissed that risk in 2012 as a silly fairy tale, citing Autostrade's own 2009 evaluation, suggesting the bridge would last another 100 years. In 2016, Italy's then infrastructure minister was informed, multiple times in parliament, that the bridge needed maintenance. You are not looking at a quiet failure. You are looking at a public argument, conducted in newspapers and parliamentary chambers, about a bridge that was in fact dying. And the people warning loudest about it, including the bridge's own owner, were being publicly contradicted, citing studies from the same owner. If the picture is starting to feel less like an accident and more like a tightening trap, you are reading it correctly. Because what comes next is where the easy story, that nobody could have known exactly when or where this bridge would fail, becomes impossible to defend. In 2017, a confidential university report on the bridge noted severe disparities in the behavior of the stays, specifically at Pillar 9. Pillar 9, by name, that is the exact pillar that fell the following year. The minutes of a February 2018 government meeting recorded what they called resistance and reflectometry measurements, indicating an average 10 to 20% reduction in the cross-section of the bridge's tendons. And in the weeks before the collapse, a crack in the road surface had appeared, by some accounts at least 14 days in advance, near the southeastern stay of that same Pillar 9. The exact location, the exact element, the exact direction. You can no longer say nobody knew. You can no longer say the danger was theoretical. The specific pillar, the specific weakness, and the specific magnitude of the damage had all been documented in writing, in different documents, by different bodies, in the months immediately before the disaster. So the question isn't how it happened. The question is who had the authority to act on that information, and why didn't they? And here you run into the thing that has reshaped how Europe talks about privatized infrastructure ever since. Autostrade, per l'Italia's parent company, also owned Spea, the engineering firm formerly responsible for inspecting and maintaining the bridge. Read that again. The company being inspected and the company doing the inspecting were, in functional terms, the same organization. Despite the February 2018 findings of a 20% strength reduction in the tendons of a bridge approaching its 60th year of service, prosecutors would later argue that neither the ministry nor the highway company ever considered it necessary to limit traffic, divert heavy trucks, reduce the roadway from 2 lanes to 1, or even reduce vehicle speed across the structure. The bridge kept carrying tens of thousands of vehicles a day, until it didn't. On the afternoon of the 14th of August 2018, during a rainstorm, the southern stay cables of Pillar 9 and the road sections attached to them dropped almost simultaneously. A 210-meter section of the viaduct, the entire tower, and the vehicles on top of it fell into the valley below, onto the riverbed, a railway line, and the buildings beneath. 43 people were killed. Around 600 residents in the surrounding buildings were evacuated and lost their homes. The most widely accepted mechanism, supported by years of inspection and corrosion data, was corrosion-related cable failure on the stays of Pillar 9, though the formal legal cause has remained contested in court. The defense in a later trial argued the collapse resulted from an original construction defect rather than maintenance negligence. The prosecution argued the opposite. The truth, per the available record, likely involves both, and that dispute is part of what is still unresolved today. Here is the trap that closes the whole story. You cannot retroactively unbuild a bridge whose protective feature is the same feature blocking proper inspection. You cannot trust a self-regulating inspection system that found documented damage and still didn't restrict traffic. And by the time the danger was undeniable, the only remaining option wasn't reinforcement. It was demolition and full replacement. The legal reckoning has moved roughly as slowly as the original maintenance did. In July 2024, 6 years after the collapse, the first criminal trial concluded with the conviction of 18 former executives and employees of Autostrade per l'Italia. A second trial, addressing broader alleged irregularities in the management and maintenance of the region's motorway infrastructure, began in January 2025, involving 46 additional defendants, including the company's former CEO. Some of the charges in that case have already been dismissed under Italy's statute of limitations, meaning they ran out of time before they could be heard. Following the collapse, the Italian government negotiated a deal under which the Benetton family agreed to sell its ownership stake in the company that had controlled the bridge. 6 years for a first verdict, a second trial still running, charges expiring before they could be tested in court. None of that gets the 43 back. None of it returns 600 people to their evacuated homes. So look again at what stands in Polcevera today. A new bridge, designed by a Genoa-born architect, opened roughly a year after the collapse. Built fast, built clean, built with a different set of priorities. 43 lamps, lit at night, 1 per victim. The replacement is the opposite, visually, of what came before. The old bridge concealed its decay inside a concrete vest. The new bridge wears its remembrance on the outside. But the thing that allowed the old bridge to keep operating, well past every warning, was not really concrete. It was a system, privatized infrastructure inspecting itself. Warnings filed without consequence. Design choices made for appearance over verifiability. Repairs proposed and refused because they would have looked wrong. A document chain that named Pillar 9 in 2017, that measured the cable loss in February 2018, that recorded a road surface crack 2 weeks before, and a public that kept driving across it because nobody told them not to. That system was not replaced along with the bridge. It was studied. It was debated. It prompted other countries to look harder at their own inspection regimes. Whether it has actually been fixed is, in places, still an open question. The second Genoa trial is still asking, Building infrastructure is the part that gets the ribbon cutting. Maintaining it is the part nobody photographs. The Morandi Bridge worked, for years, while warnings about it stacked up inside drawers and on parliamentary record. The new bridge stands. The lamps are lit, and the harder, slower question the old bridge raised, about who is allowed to mark their own homework, on infrastructure that millions of people trust, without ever being told to, is the one Europe is still trying to answer. A bridge can hide its own failing for 50 years, if you let the design do the hiding. The reckoning, when it arrives, does not arrive on the bridge's schedule. It arrives on a rainy afternoon in August, in seconds, on top of the people who were never given a chance to know.